Good morning, guys. Today we're going to continue on our notes for transformations. This is notes 3.05. We're going to be talking about vertical dilations. Okay, and this is considered a non-rigid transformation, meaning that it's actually going to change the shape of the function. And in this case, dilation, it's going to be like you can call it like stretching or compressing, but we call it expanding and compressing. So vertical dilations are transformations that change the shape of the graph either by expanding or compressing it. So that's what we're going to be looking at today. So we've already looked at, just to kind of summarize what we've seen reflections, we've seen horizontal translations and vertical translations. And so to add to the transformation, we're going to talk about sorry about that. This should say not reflections and translations. It should say dilations. So this part here should say non-rigid transformations. Okay, talking about expansion and compression. So to kind of show you an example, let me just do an example using, I'll do it here. Okay, since we're already in this window, let me just check to see if we're in a good position. Okay, so let's say I'm just going to do a rough sketch. So let's say we have our y-axis, our x-axis here, and let's say we have the parent function is a quadratic. So I'm going to do it in purple. This is my parent function. And if I have a expansion, I'm going to do an expansion in blue. What it's going to do to the parent function is it's going to cause it to kind of squeeze a little bit closer because we're pulling this parent function up vertically. And so if you pull it up vertically, it's going to bring the U kind of more closed. So this is this blue one is an expansion, and that happens when there's a number that's greater than 1. And I'll show you in the examples when we go over it. And then an example of compression would look like this. So compression causes this U shape to get a little bit wider. Okay, so we have the parent function in purple. We have the compression, or let's say the expansion. And this red one is the compression. And so it's kind of, the expansion is, again, squeezing the U shape kind of closer together. And the compression is causing the U shape to get a little bit wider, open a little bit more. But it still keeps the same original function, like this purple parent function. But expansion and compression do two different things to the shape. So it actually changes the way that the shape looks. Either closer together or more spread out. And again, we're going to look at examples so that it can make more sense. And everything makes a lot more sense once we look at examples. So let's jump to the first example, which I set up over here. And so first off, let's state the type that we have. We have these vertical bars, which means it's an absolute value. And so the key points there are, it's negative 1, 1, 0, 0, 1, 1. Okay, so that's going to be these 3 points. Right, so it's giving us kind of a V shape, right? And so we're going to have something like this. Oop, I don't like the way that came out. It's a little bit better. And then going the other way. That's the best that I'm going to do right now. Okay, so we have this absolute value, and then we got to see what's happening to it. And the only thing that I notice is there is a 3 in front of it. There's a 3 in front of it. And so it's positive. And so the question is this going to be a expansion or compression? And the rules were if this is greater than 1, if it's greater than 1, then we have expansion. And so what this expansion does, what vertical expansion and vertical compression do, is that they affect the y values. Okay, so whatever you're expanding by, that's what we're going to multiply these y values on the table by. Okay, so then let's do that. Let's take this 3 and multiply it into these y values. So times 3 times 3 times 3. And so that's going to give me positive 3. 3 times 0 is 0. And 3 times 1 is 3. So if we plot these points, we're going to plot negative 1, 3. So remember, this is negative 1, this is positive 1, 0. And so negative 1, 3 is this way and then up here. So it's going to be, it's going to be this value here. And we still have the point 0, 0, 0, 0 is still there. And then the last point, 1, 3. So I'm going to go 1, 3. And then I'm going to take my ruler and connect these points. And it still has the same V shape, but if you notice, it's a little bit more together, or closer together, I guess you should say, closed a little bit closer together. Okay. Again, so, and we're going to keep practicing this, but basically this is what vertical expansion and compression does, is whatever you're multiplying the parent function by, we're going to multiply all the y values by that expansion value. And then we're going to get a new set of points to plot. So the new points were -1, 3. The x's didn't change, only the y's changed. So it's -1, 3. -1, 3 is this point. And 0, 0 stayed the same. And 1, 3 changed. So it's 1, 3. And I just want to write there so we remember. The blue one is the parent. The red one is, I'm going to just call it the transformation. Okay, and again, we're going to keep practicing this. So let's go over to the example 2. Let's keep practicing. All right, so let's identify what type it is. It's a cubic because it's to the power of 3. It's x to the third, 1/2 x to the third. The values for a cubic are -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. So that's going to give me the following parent function. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so let's see what's going on over here. There's a number being multiplied in front of the parent function, right? In front of x to the third. If that number is less than 1, then we have what's called compression. We have compression. Okay, and so again, what are we going to do with the y's? We're going to multiply all these y's on the table. We're going to multiply them all by that number that I circled, which is 1/2. 1/2. 1/2, 1/2, 1/2. Okay, so let's calculate. What is 8? -8 times 1/2? That's -4. What's -1 times 1/2? That's -1/2. Or we can say -0.5. 0 times 1/2? 0. 1 times 1/2? It's positive 1/2, 0.5. And I'm going to show you why I'm writing these in decimals, because we're going to plot them on the graph. And then the last calculation equals to, what is 8 times 1/2? What's half of 8? That's 4. Okay. So let's plot these points. Notice that the x's don't change, but the y's do. So let's plot the point -2x, -4y. -2x and -4y. So that's going to go -2, 1, 2, 3, 4. It's going to go here. So that's 1, 2, and then 1, 2, 3, 4. Okay. The next one is -1, -0.5. -1, -0.5. That's about there. -1, and then half a step down. So not a full step, but half a step. Then the third point, 0, 0. That's the same one that was in the middle. The next point is 1.5. 1 and 0.5. So that's going to go, I'm going to go 1 to the right and half a step up. And then the last point, 2, 4, 2, 4. So I'm going to go 2 to the right and 4 up. 2 to the right and 4 up. Right, so if I connect the points, I get the following graph. So it's kind of a slight difference, but the key difference is, how the points are changing, because the y, we were changing all the y's in the table and getting new points to work with. Okay. And notice, even the thing that happens here is in the parent function, when I went 2 to the right, it goes 8 steps up. But when we have a compression, in this case, the compression was 1/2. It cuts the distance in half. So what's half of 8 steps? What's half of 8? That's 4 steps. So instead of the graph going up 8 steps, it goes only up to 4 steps. Same thing down here. Instead of going down 8, it goes up, or it goes down 4. Same thing here. Instead of going down 1 step, it goes down half a step. Instead of going up 1 step, it goes up half a step. Okay. Let's go to the next example. And we would say this one is a cube root. And the values for a cube root is if I take the x's and the y's and I switch them, comparing to the cubic, right? So if it's going to be -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Giving me these points, and then the other ones are 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, it's right here. And then 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, and let's see what's happening to the graph. There is a -1/2 situation. Okay, so it's actually this is actually doing 2 transformations in one. It's reflecting over the x-axis, and since 1/2 is less than 1, it's compressing. But we're going to do the same idea that we did in the other ones previous to this. We're going to multiply all the y values times that number that we circled. In this case, it's -1/2. So if I multiply them, multiply by -1/2, -1/2, -1/2. Okay. This first value here equals to, what's -2 times -1/2? A negative times a negative is a positive, and half of 2 is 1. Okay. The next one, negative times a negative, -1 times -1/2 is a positive, and what's half of 1? That's going to be positive 0.5. The next one, what's 0 times -1/2? That equals to 0. Equals. And then what's a positive times a negative, that's negative 1/2, or negative 0.5. And then the last one, positive times a negative is a negative, and what's half of 2? 1, so negative 1. Okay, so let's plot these points. We're going to do negative 8, 1. Negative 8 is over here, and then we're going to go down, we're going to go up 1. It's negative 8, 1. Next one, what's negative 1 and 0.5? Negative 1 and negative 1 and 0.5 is about here. If I go negative 1.5, 0, 0, that one doesn't change, so that point stays the same. The next one is 1 and negative 0.5. So 1 and negative 0.5. And then the last one on the table, 8 and negative 1. 8 and negative 1 is over here. And so I'm going to connect these. Okay. So again, the blue one is the parent, the red one is the transformation. So notice that I said there's a reflection happening. You notice the points that were on the bottom on the parent function are now on top, and the points that are on top are now on the bottom. And there's a compression happening. The distances were cut in half, right? What's half of 2? 1. What's half of 2? 1. What's half of 1? 0.5, 0.5. Okay, and again, I'll go over these in class just so we're clear what's happening. Let's go to the next example. So the type of function we have here is a square root. That means we have the following points. 4, 2, 9, 3. Okay, so we have 0, 0, 1, 1, 4, 2, 5, 6, 3 is over here. And then in the graph, we have a negative 2. So that's doing a reflection and expansion. Then we have the plus 1 here, which means that we're going to the left 1. And the minus 3 means that we're going down 3. And usually we do things by the order that they present themselves. So we're going to do the red transformation first, then the green, and then the purple. Okay, so for the red transformation, that means we're going to multiply all the y values times negative 2. So if I multiply all these values times negative 2, what does that give us, right? 0 times negative 2 is 0. 1 times negative 2 is negative 2. 2 times negative 2 is negative 4. And 3 times negative 2 is negative 6. Okay, so let's plot these points. 0, 0 is right here in the very center. The next point is 1, negative 2. this point here. 1, negative 2. 4, negative 4. That's 4, negative 4. 4, negative 4. And 9, negative 6. 1, 2, 3, 4, 5, 6. Okay. And then before I complete the points, or before I connect them, I'm going to move everything, because we have to move all the points to the left 1 and down 3. So let's do the movements. We're going to go to the left 1 and down 1, 2, 3. You know what? I'm gonna do the transformation in a different color. I'm gonna do it in let me do it in pink. Okay, so this one here, and then 1 to the left, 3 down, 1, 2, 3. Then 1 to the left, 1, 2, 3. And then the last one, 1 to the left, and 1, 2, 3. Okay, so that's going to give me, disconnect it. Following graph. All right, so we have the parent is in blue. The transformation for this problem is in pink, because I didn't want to use red twice. Okay, so again, to recap what we did the reflection expansion by multiplying all the y values times negative 2, giving us new y values. So we plotted these new points. Then we moved all these points to the left 1 and down 3, giving us our final transformation. Okay, let's go to example 5. In this example, we have quadratic. So that's that U shape, right? So 0, 0, 1, 1, 2, 4. Okay, and then we have in here times 3, so we have in expansion the x minus 4 means that we're going to go to the right 4, and the plus 2 means that we're going to go up 2. Okay, so let's do the expansion first. Let's multiply all these times 3. 3 times 0, 0. 3 times 1 is 3, and 3 times 4 is 12. Alright, to make sure that it fits, I'm going to scoot the graph down, maybe up to there. Or let's go 1 up. Let's go there. Okay, so then let's plot these points. It's 0, 0, 1, 3, and 212. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 3 past the arrow. So around here. And so if I draw the other points, because it's going to create a U shape, I'm going to draw another point here. And another point right here. And again, I'm not going to connect the points yet because we need to do the transformation. So the transformation, or I mean the translations, we have to go to the right 4. 2, 3, 4. Actually, let me move this point first. So we're going to do 1, 2, 3, 4, and 2 up. Oh, and then let me use pink again. All right, and then we're going to do 1, 2, 3, 4, 2 up. So I'm moving this point 4 to the right and 2 up. Just give me this point. And then 1, 2, 3, 4, 1, 2. And then copying the other points. That location. Okay. Awesome. So this gives me a quadratic function that does this number. Awesome. So the whole graph was moved to the right 4 and up 2, but there was also this expansion that happened. So this is my final transformation graph, this pink one. All right. Let's go to example 6. Example 6 and 7. These are like what we did, I think, on the second set of notes, where we have to write an equation given the following information, right? The parent function and the transformation. So let's do that. What color do I want to choose? Is the question. Okay, so I'll do that. I'll do blue. So it's absolute value for number 6. So that means it has the absolute value of x, something like this. Expands by a factor of 4. So multiply by 4, and then translates 9 units down, so minus 9. Okay, so my function equation is going to be the absolute value of x multiplied by 4. So let me make space for the 4. So it's going to be 4 times the absolute value of x minus 9. So we have the absolute value function. It's being multiplied by 4 because it says it expands by a factor of 4, and it's translating 9 units down, so minus 9. So my final answer without any colors on it is 4 absolute value of x minus 9. Again, I'm just color coding so you can kind of see where I'm getting the pieces from. Example 7, the last one, it's cubic, so that means it's x to the power of 3. It reflects, so these two, I can combine them into one transformation. It's going to be multiplying by negative 1/2. And then we have translating 3 units to the right. That's minus 3. And 7 units down, that's minus 7. So the function that I get is I'm going to multiply times negative 1/2. And it's going to be let me write it like this. X is going to be to the 3rd power x minus 3 minus 7. So let's see. It's reflecting because it has a negative. It's compressing by 1/2. It's cubic because there's a power of 3. It's translating 3 units to the right, so I put minus 3 inside. And it's going 7 units down, so I put minus 7 outside. So my final answer without all the colors is negative 1/2 x minus 3 to the 3rd power minus 7. Awesome. So this concludes our notes for today. Again, if there's any questions on any parts that I went over today, you can bring those up in class and we can go over them. But other than that, guys, thank you for joining me. I'll see you guys in class.